Now, I've mentioned a few times this head in all caps. And we've also been using the names of branches, right? That new dash branch and main in commands. And these are what's called references to specific commits. Branch references, like new dash branch or main, refer to the tip or the most recent commit of a branch. And this may also be called the head in lowercase, not to be confused with head in all caps. So head in all caps refers to the current commit, which is the one we're looking at right now, the one we're what's called working on in air quotes, right? So usually head is a head. Head in all caps is a head lowercase, or the tip of a branch. But we can move it anywhere we want and look at or work on files as they were at that commit. So this is called a detached head state. So usually it looks like something on the left, our graph, right? We're working on top of a commit, which is at the tip of a branch, the most recent thing that's been added to a branch. But we can also go back in time and work on top of a specific commit. So I don't have a hands-on segment for this, but we can actually just go look at how this would work in practice. So we're right here, we have head on this commit, this merge commit, right? But we can actually go check out, is what this is called, this other commit. And so now I'm actually working on top of this other commit. And if I look at my graph, you can see that head is right here. And so I could actually go in and say, like, maybe git switch dash c new branch and edit this file. You'll see this is not actually the most recent version of this, which was after that merge. So maybe I'll just add some new content. Git add hello, git commit, add some new content. And now if I look at my log, you'll see it's a pretty strange history here, right? So this is actually the main branch. This is what we were looking at before with this merge, but I've actually based this new commit off of a prior commit, which is the one from that new branch. And I'm now in new branch. So now I can actually move my head back. So git checkout main. And now I'm working on top of that commit with the merges, with the merge. So you can move around the graph with this git checkout command.
So recall that according to this Pro Git book that I mentioned earlier in the presentation, it basically takes a picture of what all your files look like when you make a commit. So if your commits are a series of pictures, then the head is the one you're looking at or working on right now. So this is an important concept when we start to discuss reverting and resetting or undoing your changes. So Git is not the same as having an undo button, but sometimes you do want to undo your changes, and reverting and resetting are two ways of doing so. First, I want to note that there are a few different strategies for going sort of back in time in your Git repository. And non-destructive operations are always preferred if you're working with other people. That is, if you've already shared your repository with others. Because actually deleting information could cause problems. Let's say you upload all of your files to something like GitHub, and then someone downloads those and starts working on top of them, and then you say, oh, actually I don't want some of these commits, and you push changes to GitHub that don't include some of your prior commits. So now you've gone and like erased part of your repository's history. Now when this other person who's working on this repository tries to sort of sync up with GitHub or copy files down from the repository, there's going to be a difference between their repository and the remote. And this can cause problems and will cause some manual labor to be done on the part of the person who's trying to sort of sync up their repository and the one from which you've deleted information. So it's kind of a long-winded way to say don't delete things you've already shared with other people because they may be relying on those things. So reverting is a non-destructive option for undoing changes. So this is something that I'd prefer to do if I were working with other people. It will always create new commits, so it doesn't remove anything from the project history. And there are a few quirks that you should be aware of before you start reverting, and they're listed on the handout. Notably, reverting only undoes one commit at a time unless you specify a range. So if you say git revert and then some commit hash, it's going to undo the changes in that commit and that commit only. So it's not like it's going to revert back to some prior commit that's several commits removed from the current location of the head. So that's just something to be aware of. So in practice, what does this look like? Let's say we have 3 commits and we want to revert back to the first one. So I use the word revert there a bit loosely. Really what we want to do is revert 2 commits to get back to this original commit that we have on the far left here. And in doing so, of course, reversion is an additive process, so we're actually going to add commits. And in this case, we have the changes plus ABC plus DEF, just kind of stand-ins for what the content actually is there. We, in reverting these commits, subtract DEF and then subtract ABC. So we're kind of doing the opposite of what these original commits are when we're doing this reversion. And this is another quirk of reverting where every reversion of every commit will create a new commit. Now you can actually just tell it not to create commits, and in that case you can make a commit at the very end and only have one. So that is an option if you don't want a bunch of commits in your history, just saying basically I undid this other commit. So there's more information about that on the handout. Now resetting, on the other hand, can be a destructive option, and it works by moving the branch reference and the head. So I have this cartoon at the bottom here where we have some case on the left where we're trying to remove this last commit from the history, and basically what reset is doing is picking up main and head and moving them to some other commit. And then this creates what's called an orphan commit. So this commit still exists somewhere in space, right, in your repository, but it's not actually deleted until Git runs what's called garbage collection. So if you do this accidentally, you can potentially recover your changes, but you need to do so pretty quickly before Git actually cleans up this sort of orphans commit here. And there are a few quirks about this that you should be aware of, as with reverting. So please refer to the handout for more information before you actually use this in practice. Now you can also just work what's called on top of a specific commit. This is just moving head, but not any branch references. You can do this with git checkout and then some identifier like a commit hash or a branch name. Reverting, again, you use git revert and then the commit, and this only operates on one commit, as I mentioned earlier, unless you specify a range. To reset, the command is git reset, and this has a few different options which are detailed in the handout. These options just refer to whether the information in your working tree and in your index is kept during the reset. I have another hands-on exercise here, which is to create a new commit, compare the differences between this commit and the last commit, revert this new commit, and then again compare the differences. Then we'll check out a previous commit, make a new branch, and this will just show that we can sort of work on top of another branch, which I've already kind of shown previously, but I'll do it again just for the sake of completeness. And then we'll look at the graph again, at the log. So let's create a new commit. Let me look at my files here. Let's modify this file hello. So here's some new content, but I'm just going to note that since step 2 is to revert this commit, that I will just end up reverting immediately, right? So I will go ahead and add hello and create a commit. Okay, so I've made this new commit. I can run git log -- graph -- all. You can see here's my new commit on the main branch. I can run a git diff between the earlier commit and the later commit. And we can see I added a blank line, and then this text, here's some new content that I will just end up reverting immediately. Okay, so now we can move on to step 2, which is to revert this commit. So I want, again, this commit hash, and I can just say git revert and then the commit, and this will undo the changes in that commit. So it has a default commit message here. I'll just approve that. You can look at our graph again. We've added a new commit. Again, revert is additive, so it's not actually going to delete the content in this commit. It's just going to add a new one that undoes it. And then we could again look at the diff between now this as the earlier commit and this as the later commit. And we can see it does the exact opposite of what the other commit did, the commit I just reverted. And in this case, we're subtracting a new line and subtracting that line of text that I added. Alright, so we're done with steps 1 and 2 here. We can move on to step 3, which is to check out a previous commit. How do you see previous commits? Well, we've kind of answered that with this git log structure here, git log command. So let's just pick some commit arbitrarily. So I already did some of this in a previous hands-on exercise. I just kind of went off on a tangent, but we can do it again here. So right now I have a head at the tip of branch main, and what I'm going to do with this git checkout command is just move it to a different commit. So I'll run this. It'll give me a little warning here. It says I'm in a detached head state. That's what we expect. So we can look at our graph again, and head is now just associated with this random commit. It's not at the tip of a branch anymore. And again, we could switch to a new branch, and we could add some new content. And look at our log again. And of course, now head is at the tip of a branch. It's at our new branch that we just created, which is based on an earlier commit. So this, again, we've seen a bit earlier, but it's just worth reiterating. You can sort of go back in time with this git checkout command and look at prior commits and work on top of prior commits. So we just created a branch on top of a prior commit.